Good morning, this is Dr. Turner for Integrated Math 3. Today we're going to be finishing the last section of Unit 3, which is 3.5, Solving Polynomials. This is an extension of the last few sections that we've covered. We've talked about how to divide, how to factor. Really, solving polynomials is just adding one additional step, and it's really the goal of what we've been working towards for 3.3 and 3.4. I'm only going to cover a few examples here in the video. We'll cover more in class. Remember, there are additional resources available on Schoology if you feel like you need some help, or please schedule an appointment with me during office hours. So this is what this is going to look like. Okay. Let's say we start back on the first part of 3.3 or 3.4, and for these, remember that we took multiple days to do these sections. So for 3.5, let's say I had something like x squared minus 8x plus 12. Now back in Math 2, we talked about different ways that you could solve this. We were focusing on factoring because we were looking at polynomials. So to do that, you do the magic x, and you're looking for the numbers that multiply to get 12, but add up to negative 8. Those two numbers are negative 6 and negative 2, which means in factored form, this is x minus 8 times x 8 minus 6 times x minus 2. And the only difference is that we're adding that equals 0. And this should look familiar from Math 2. To solve a quadratic equation, or any polynomial equation, if I want it to be equal to 0, I can have the left side equal to 0 or the right side equal to 0. So I'm looking for the values of x that would make this a true statement. Well, if you need to, you can write in this extra step here. You do x minus 6. What would make that 0? Set it equal to 0. And x minus 2 equals 0. Set that equal to 0. These are just one-step equations, which hopefully we can do by now. If I add 6 on both sides and I add 2 on both sides, I get x equals 6 and x equals 2. If you recall, we said that in polynomials, the most solutions you can have is the degree of that polynomial. So if I'm looking at quadratic functions, at most I can have 2. That doesn't mean there will always be 2. It means at most there will be 2. And in this case, we ended up with 2. This applies for special cases of quadratics as well that we also covered. So let's say I'm looking at a difference of squares. X squared minus 64 equals 0. And again, there are different ways I could factor this, or solve this rather. But if we're solving by factoring, this is a difference of squares. So x minus 8 times x plus 8 equals 0, which means my answers are positive 8 and negative 8. Or you can just put it together and write plus or minus 8. If you have a quadratic that has a leading coefficient of something other than 1, process is the same, 6x squared minus 5x minus 4. So if I'm solving this, I'm still going to do the x. Remember, it's a times c on the top now, so 6 times negative 4. And my b is negative 5. So I'm looking for two numbers that multiply to get negative 4, but add up to negative 5. So typically I'm starting with a product, say 8 and 3. And then I'm going to make the 8 negative because I want it to add up to a negative 5. Now remember that usually we'd be done if a was 1, I would just write x minus 8 times x plus 8 times x minus 3 equals 0 and be done. However, a is something other than 1, so remember the next step is that we have to divide each of these by the a term. So you divide those by 6. And reduce if you can. This becomes 4/3. Here, this becomes 1/2. Set each of those equal to 0, and we get x equals negative 4/3, and x equals positive 1/2. So same factoring, just adding an additional step. Always be on the lookout for quadratics or any polynomial that have a common factor. So let's say I had 4x squared plus 20x plus 16 equals 0. Now you could automatically just start and do the x and multiply, but if they all have a common factor, what that typically means is that there's going to be something I can pull out, and if I do that, it's going to make doing the process a little bit easier. I'm going to have smaller numbers to work with. So if I do that here, I see that 4, 20, and 16 are all multiples of 4. So I'll divide out that 4, or divide out that 4, to give me x squared plus 5x plus 4. And these are much smaller numbers to work with. The numbers that multiply to get 5 but add up to 4. Or sorry, the numbers that multiply to get 4 but add up to 5, rather, are going to be 1 and 4. So this is 4 times x plus 1 times x plus 4. And I'm going to set that equal to 0. The 4 we're going to ignore. We could divide that out if we wanted to eliminate it entirely. But we'll leave it there because this is factored form. If I set each of these equal to 0, and solve the one-step equation, I end up with -1 and -4. Notice here that when I get the factored form, like x plus 1 times x plus 4, the signs end up, of the solutions end up being the opposite sign. And that's true all the way across. When we started, I had x minus 6 times x minus 2. My solutions were x equals positive 6, x equals positive 2. Even down here in the bottom left, where we ended up with fractions, the solutions are the opposite sign of the factored form. So that is all to say, after you do these for a while, you can kind of skip this step. If you're first starting out or you're still a little uncomfortable, I recommend you do that so that you're not missing anything. But you can kind of get away with taking the opposite sign after you do this for a while. I'll clear my highlighting here. Okay, so those are all well and good, but what if I have a higher level polynomial? So let's say I have something like x cubed minus 14x squared. Oh, we'll change this. Let's make it minus 15x squared plus 62x minus 48. I'm going to set that equal to 0. Now, typically, if you're looking at an integrated math textbook, unless you're in an advanced class, the book is going to ask you more to see if is 1 a solution to this, is 2 a solution to this, and it might specify use this type of division, like use synthetic division. There are a few strategies to do this. Now, for our class, when we're looking at this, my recommendation is synthetic division. So you're going to take the last term, which is -48. You're going to divide it out by the a term, the leading coefficient, which is 1. And so I'm looking for multiples of 48 that are factors of 48 rather that can go into this synthetically. And so that's a big undertaking, right? That could be a lot of numbers. But once you learn synthetic division, it goes pretty quick. So this is how I would do this. And of course, there are multiple ways you can. I'm going to start out with just a positive 1 because I know 1 is a factor. So I'm going to write 1 on the outside. Remember, you write your leading coefficients. So 1, -15, positive 62, -48. Okay. So the first one, you always bring that down, whatever the leading coefficient is. And so we're going to multiply 1 times 1. Add straight down, and repeat. 1 times -14, add straight down. 1 times 48, add straight down. And getting a 0 here at the end, that's what we want, because that means I have a remainder of 0 when I did the synthetic division. So what does that mean? Well, now we can write this in factored form. This is x minus 1. Remember, it's always the opposite sign on the outside here. So it's x minus 1 times, and I have 3 numbers. So going from constant up, constant linear, this is going to be a quadratic function, x squared minus 14x plus 48 equals 0. So for sure, I already know that x equals 1 is going to be a solution here. X squared minus 14x plus 48, that might be something that I can still factor. And because this is cubic, remember we said that whatever the degree of the polynomial is, that's how many solutions are possible. So because it's a cubic polynomial that I'm trying to factor here, potentially I can have up to 3 solutions. So we found one. Now I'm going to use factoring to try to find the others. And this is just my method of doing it. Of course, there's more than one way you can do it. To factor out that quadratic there, I'm looking for numbers that multiply to get 48, but add up to negative 14. That ends up being negative 6 and negative 8. So all factored, this is x minus 1 times x minus 6 times x minus 8. That's equal to 0, which means my 3 solutions are x equals 1, x equals 6, and x equals 8. Remember, again, it can be up to 3. You might get a duplicate, you may only get 1. But that's how we would factor using synthetic division. So go ahead and take that in here. And we're just going to scroll this down. This will be up on the notes if you need them. Yeah, that should be enough space for us. Okay, so looking down here, let's do another example. That same thing of synthetic division. This time I'm going to do x cubed plus 8x squared plus 21x plus 18. That's equal to 0. I want to solve. So the numbers here, I got lucky on the last example that we did up here. I just happened to start with 1. Remember, what you're doing is you're taking the last term, you're dividing it by the leading coefficient, the a, and so the possible numbers that you can try are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 18, plus or minus 9, plus or minus 6. Right? Those are all potential solutions for this quadratic. Really, it's just a matter of doing the synthetic division. Sometimes you got to do it more than once. So let's say I chose positive 1 last time. Let's say I choose a negative 1. So same thing, write out your leading coefficients, 1, 8, 21, 18. You bring down the 1, and that's 1 times negative 1, add, 7 times negative 1, add, 14 times negative 1, add. So here, because I didn't end up with a 0, that means that that's not a factor. I can't factor that. It's not a solution to this polynomial. So then you try again. Let's say you go to a positive 2. Okay. So I'm going to try a 2. Same numbers inside, 1, 18, 21, 18. I'm going to bring down the 1. And so I have 2 times 1. Oops. We are going to do 2 times 1, but I'm bringing down a 1 here. 2 times 1. Add straight down. 2 times 10. Add straight down. 2 times 41. Add straight down. So here, one thing is that, a couple things you want to notice here. First, obviously we didn't get a 0. That means it's not going to be a factor. That's one thing to notice. Also, notice here that the number continued to grow, continued to increase and increase. If all of your terms are positive, right, 1, 8, 21, 18, if all of your terms are positive, for this to work, you're going to need to plug in a negative number. At the very least, then, when you're multiplying, it can alternate between a positive and a negative, or increase and decrease. So that kind of rules out here all the positive numbers. 1, 2, 3, 6, 9, 18. All the positives, they can't be solutions, because that's what I got by plugging in 2. Right? If I plug in 3, I'm going to get something even bigger than 100. So let's try a negative 2. So I'm going to plug in a negative 2, 1, 8, 21, 18. Bring down the 1. So we do 2 times negative 1 and add straight down. 6 times negative 12, add straight down. 2 times negative 18, there we go, add straight down. We got a remainder of 0, which is what we wanted, which tells me that negative 2 is a solution. If that's all I was asking you, you'd be done, but I'm asking you for the solutions to the whole polynomial. So flip the sign, write it x plus 2 times, looking down here, 1, 6, and 9, x squared plus 6x plus 9. I still have x plus 2, and I know the solution is negative 2, but I need to factor this right side if I can. This is your perfect square trinomial for when x equals 3. And you can get that by doing the magic x if you'd like, but it's x plus 3 times x plus 3, or x plus 3 squared, which means your solutions are negative 2 and negative 3. Now, for all of these, my goal for you is to be able to factor, to use long division, to do it algebraically. Even though that we're learning online, I still want you to be able to do it as though we were in person. Now, can I see your screen? Absolutely not. Can I keep you from cheating or plugging in something? Absolutely not. If you're going to cheat anyways, which I am not encouraging, I would use Desmos, because remember your solutions, another word for solutions are your factors or your zeros. So let's say I was getting caught up on the synthetic division, or let's say I did a great job on the synthetic division and I wanted to make sure that my answer is correct. Well, pull up Desmos, and let's say we take a look at that last one we did, x cubed, remember caret for the exponents, plus 8x squared plus 21 plus 18, and you can put the equals 0 if you want, you don't have to. Oh, 21x, thought that looked a little funky. So then if we zoom in, just like we got algebraically, our solutions, or our x-intercepts, are negative 3 and negative 2. So I strongly encourage you not to cheat, but if you're going to cheat anyways, at least understand what these intercepts or solutions mean in terms of the problem, and you can use Desmos to verify. Well, that's it for today, guys. If you have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.